Thank you everyone for being here. I look forward to sharing with you some really interesting insights about designing controlled environment agriculture projects like greenhouses and indoor farms. This is the October webinar from the Greenhouse Lighting and Systems Engineering Academic Consortium out of Cornell University. I'm Gretchen Schimmelfennig, the Executive Director, and our mission is to transform greenhouse lighting and systems management to support climate smart CEA. And our researchers check out the leading edge of LED systems, engineering, plant photobiology, greenhouse controls, and ultimately seek to commercialize emerging technology, save growers money, and reduce the carbon footprint of greenhouse operations. You may know us from our researchers. We have Cornell, Rensselaer Polytech, and Rutgers University researchers looking into emerging tech and checking out the latest advances in impacts on crops of things like lighting and controls. We share educational insights through our webinars and short courses. So thanks for being here. We hope you consider attending our 2024 short course, which will be on advanced greenhouse coverings, curtains, and supplemental lighting. And maybe you'll be attending next week's summit in Leamington, Ontario, where we'll be networking with our members and industry interested folks from Canada and the US, all across the industry. So we hope that you consider joining one of our networking events next year or in the future. You can join GLASE and check out member benefits online. We appreciate having nearly 30 industry members and CEA farms as part of GLASE. And just want to let you know a little bit about the past webinar topics and our upcoming webinars so that you get an idea of what's in it for you coming in our 2024 webinar announcements. So in 2023, we presented on combined heat and power, lighting modulation for targeted enhancement in food quality, a panel of small-scale CEA growers. We learned about hemp lighting research from Cornell, and GLASE researchers gave a showcase of their latest findings. We also heard from Schneider Electric about their vision of a sustainable life cycle in CEA, and the Virginia Tech researchers and the Institute for Advanced Learning and Research from Virginia presented about AI technology at their Controlled Environment Agriculture Innovation Center. Lots of words. So anyway, in November, we hope that you tune in for our last webinar of the year from a University of Georgia researcher about the effects of light spectrum on nutrient uptake, and stay tuned for our upcoming webinar announcements. So that is going to happen on November 16th at 2 p.m., same time, same place next month. And with that, I encourage David to introduce himself and tell us a bit about what we're going to hear in today's webinar.
Okay, hi everyone. Gretchen, it's not letting me start my video. So if you can update that.
I'm going to let you do that now, I think. Sorry for the technical Zoom setting. Maybe it should allow you now.
Okay. Nope, it's still giving me says the host has stopped it.
I have it set that host and panelists can share. So what I'm going to do is I can share your slides, but ultimately I am not sure what's happening in regards to the sharing setting.
Let's see. Let me see if I can share my screen.
Mm-hmm.
No, it's not letting me share my screen.
Do you want to try now? I tried to do another setting that maybe would make a difference.
Okay, now it's letting me. Okay, perfect.
Sorry about that, everyone. You never know with Zoom. All right. I see my stuff right now.
Okay, a second while this is loading. So I'm assuming everyone can hear me fine. Thank you to GLASE and to Gretchen for inviting me to be part of this webinar. My name is David Caesar, and I work with a company called Agritecture Consulting based out of New York. Today's webinar, we're going to be talking about using design software to create financial models for CEA. And our agenda is as follows. I'll give a short, very brief introduction about myself and about Agritecture. Then we'll talk a little bit about the recent challenges to the CEA industry and some of the common mistakes that we see in the industry. After that, we'll do a software demonstration with our Agritecture Designer software, and I will try and focus this particular webinar with a little bit more of a technical edge, because I know probably the audience is a little more interested in understanding how the software, some of the technical aspects of the software itself. And then in the last portion, we will open it up for questions. So a little bit about myself, just so you have some context for the type of work I do. I started out many years ago in field agriculture. I'm based in California. And yeah, really began my work in field agriculture, mostly in California's Central Valley. So I was working on and managing farms in the 10, 12 acre size, growing seasonal vegetables. So everything was soil based. In 2012, I was introduced to CEA and began to work in and manage a vertical farm, one of the first vertical farms, I think, in the US. That was in 2012. And so that was really my introduction into hydroponics, into CEA. And then since 2016, I've been working with Agritecture as the lead agronomist. And today, of course, we're going to be talking about Agritecture Designer, which is our software for helping folks plan farms. And what I do in relationship to Agritecture Designer is I create the logic for the back end. So, for example, helping to figure out, how to crops and their yields, the costs that go into the financial models that you'll see later on. So I also want to tell you a little bit about Agritecture, just so you have as well more context about why we decided to develop software. So Agritecture was formed, we just had our 12th year anniversary. So Agritecture was formed 12 years ago in 2011. And it was founded by Henry Gordon Smith, who is our founder and managing director. It began as a blog. So Henry was very, very interested in urban agriculture at that time, but little was known about urban agriculture in CEA, especially in the United States. So he began to blog about, urban ag, CEA, and through that blog, people would write to him and ask him questions. Hey, tell me more about this farm. How much does, he'd go visit a greenhouse, post some pictures, describe, what crops they grow. And people would write in, oh, can you tell me, how much that farm was yielding? How much does that farm cost to operate, et cetera, et cetera. And so that's how a consulting business was born, just out of his sharing of his experiences at these different CEA operations, and then people, beginning to ask questions. So Agritecture Consulting was founded in 2014. And now we offer a variety of services related to the CEA industry. And then, as I'm sure you are aware, consulting is not cheap. And also, it is basically, most consulting is for clients who are, fairly well along in their project development. And, we, as one of the leading voices in the CEA industry, we get lots and lots of inbound requests asking basic questions about CEA, right? How much is it going to cost to start my farm? what will the yields be? What crops should I grow, et cetera, et cetera. And frankly, a lot of people who want to learn about these things but don't want to spend a lot of money or don't have a big budget. So we decided in about 3 years ago to create Agritecture Designer, which is a software tool created to help folks really get a basic understanding of the CEA industry and to begin to create financial models and help them develop their projects. So that's why we created Agritecture Designer. And Agritecture works all over the world. We've worked with more than 200 different clients in all different countries. And so this is important to know because we try, as we work with our software, as we develop our software, we try and make it have sort of a global perspective, right? And so we take all the perspectives from the learnings that we've had and with all these different projects and try and integrate it into our software. Okay, so now I'm going to talk briefly about some industry challenges. So I'll give you a second to take a look at these headlines. But as you can see, the last kind of year and a half or 2 years for the CEA industry has been a bit rocky. And so, with all this challenging news that we've had recently, I'm going to talk about a few mistakes that we commonly see in the CEA industry and some mistakes that you can avoid when you're planning your farm. So the first mistake that we see is that entrepreneurs want to go too big too quickly, right? What we learned from our CEA census, which we've conducted for several years, is that a lot of entrepreneurs move into the CEA industry without having a lot of experience, right? A lot of them come from a tech background, a lot of them come from an engineering background, and they believe that kind of engineering can solve any problem, or and they take sort of much less of a plant science perspective, right? And so one thing that we really push with our clients is that, every farming operation is different. Every farming operation is unique. Every farming operation is different. And, it takes time to really kind of hone in things like crop performance at your particular site, right? So we really encourage our clients to start with a pilot project, help you learn about the crops you're growing, help you really refine your systems, your methodologies before moving on to a bigger operation. A second mistake that we see, and this is very common, is really an obsession with technology innovation rather than market needs, right? So many companies start out in the CEA space. They say that they want to be a farm, they want to be producing crops for their local market, they want to be providing, fresher, higher quality food. But many of them get sort of caught up somewhere along the way in the technology kind of sphere. Because CEA, and especially vertical farming, is very new, right? There's a lot of desire in the industry and with the high number of engineers to really kind of invent our own technology. I can't tell you how many times I've heard, right? We have this great new technology. We have this great new type of lighting. We have this great new type of nutrients. We have this, additive that we add to our nutrients. We have this great, amazing oxygenation technology. We have this amazing magnetic technology, et cetera, et cetera, et cetera. It goes on, right? And folks tend to somehow deviate from their original purpose of selling food and want to develop this technology, their technology. So to have a successful farm, you really need to be focused on that. And we see a lot of distraction in the industry. And so that's another mistake that we commonly see, right? Another related to this is choosing the right equipment. And that's another reason why we suggest setting up a pilot. In a pilot operation, you can trial different types of equipment, make sure you're using what is optimal for your crop and your grower and your production team, right? 73 in our CEA census, 73% of CEA operators said they would change something about their operation if they could go back in time, right? So, that's a very common mistake we see in the industry. Another common mistake we see is a mismatch between scale and target sales channel, right? So it's very important that your distribution model aligns with the size of your farm, right? The size and output of your farm, right? So if you're designing a very small farm, right, you're going to need to find clients who don't want a large volume of production. So maybe those are farmers market or direct to consumer clients, right? And if you're designing a large farm, right, it's important that your buyers can handle a large volume of product, right? You don't want to be designing a large farm and trying to sell to hundreds of small restaurant or, direct to consumer clients. So really important to align those two aspects of your project. Another very common mistake we see is just an assumption that things won't break or an assumption that things will continue to go well, right? When you're planning your farm, when you're creating your financial models, it's critically important that you prepare for interruptions, you prepare for negative scenarios. Your costs will rise, and make sure your financial models reflect that. And really, it's not only about having a profitable business model, but having cash flow is critical at all times. So you may have a great farm. You may, have a buyer lined up, but if that buyer is going to only pay you at the end of the year, right? How are you going to pay your workers and pay all your bills for the first 12 months? So this is something that is very important to keep in mind and always be considering. And finally, a last mistake that we often see is unrealistic growth expectations, right? And this can be, relating to many, many aspects of your farm operation, right? Things take longer than expected. So we often see that, operators believe they'll be able to raise money more quickly than they can actually do it, right? So they have expansion plans, but then in the end don't have the funding ready to meet those expansion plans. When they're actually building and commissioning their facilities, this usually takes longer than they're expected, right? And so the money from production, from revenue from production, often takes longer to begin than they're expecting. And things about related to improving yields. Many farms will operate a pilot farm, and then they will be planning future farms, right? And they will bake into that, okay, we'll be able to increase our yields by a certain percentage every year. But in fact, improving yields is very challenging, or can be very challenging. And so being really cautious about those expectations is very important. So those are the common mistakes that we see with entrepreneurs and with businesses in this industry. And we'd really encourage all of you folks to think about those things when you're designing your business, and do whatever is possible to avoid them. Okay, now we're going to get into a demonstration of Agritecture Designer. Give me one sec to switch screens. Okay, assume that everyone can still see that, can see my Agritecture Designer screen. Gretchen, if we cannot, please let me know. So this is Agritecture Designer. Let me go to the home screen here. And as I mentioned before, Agritecture Designer, our goal here is to lead entrepreneurs through the steps to plan and successfully set up a farm, right? And the our software has many aspects to it. We have a whole section for learning, video lessons for folks that are new to the industry. We have sections relating to crop research, to creating your brand, and things like site selection and equipment selection. But I'm going to focus today on our farm modeling tool, because this is how you can create financial models for your CEA operation. So, okay, so as you can see, I've created many farm models in our Agritecture Designer software. So you can create an unlimited number of models. And what's important to remember is that, as you're creating models, no software is perfect, right? The good news is that we've had a number of farm operators use our tool and compare the results to the farm they're actually operating. And they have given us quite good feedback that, the information is quite accurate. But that said, it may not be accurate for your specific farm. So remember that as you're using software. Remember also that no two farms are the same. There's going to be a lot of aspects to your farm which are going to be very particular. So just things to keep in mind. So right now, I'm going to use our tool to design a couple farms and show you how it works. I'm going to use our advanced modeling tool. All right, so the first thing is naming your project. So let's say I generally put a name that has a location and the crops that I'm growing, just to help me later on find particular farm models. So let's say I want to, we'll do a farm in Brussels, growing lettuce, and we'll start with a vertical farm. Okay. So project location, this is the first question, and I'm going to put in Brussels. Okay. Now, what happens at this point is, based on the location that you provide, our software pulls in climate data for that location. So we have a database which has, I think, about 10 years of the most recent climate data for each location. Of course, it's not specific to a point in Brussels, but that general area. And so we pull in 10 years of climate data that we use to build an energy model that runs within the software. So then I can choose at that point or now to model a vertical farm, a greenhouse, or a container farm. I'm going to choose a vertical farm for this first demonstration. And then I can choose, or I need to select a automation level for my farm. Low automation means that the model, the logic in the software will choose more manual methods. So there will be a lower CapEx and more OpEx relating to labor. High automation is the opposite. There will be more of an investment into automation, so higher CapEx and a reduction in labor. And medium is kind of somewhere in the middle. I'm going to choose low for this demonstration. Later on, if you want, you can change things like currency and units of measure. Then it comes to your site area, right? Are you going to build, am I going to build my vertical farm in a building that I already own? Is it something that I'm looking to buy or looking to rent, right? So I'm going to say I'm looking to buy this vertical farm. The property is going to cost me $200,000, right? And now it's asking me how large is the space that I'm going to use for vertical farming. So I'm going to say 10,000 square feet. And of course, for vertical farming, seedling height is very important because we need to run a calculation about how many layers of production will be allowed in that space. So let's assume that this is a warehouse type facility that I'm purchasing. And I'll say it's 25 feet or about, 7.5 meters tall. Based on the information that we've given or that I've added around my site area, our software breaks down the site area. So it breaks it down into things like production nursery, things that are critical for the operation of a vertical farm. And additionally, if you're using that same space for things like processing, packaging, or cold storage, you can turn these on and it will adjust the spacing as appropriate. The next step is to choose your crops. So when here we have a drop down of crops that you can choose for your vertical farm. Now, the crop list will change depending on if you've chosen a vertical farm or a greenhouse that you're modeling. We do have, so generally we have crop types here, so things like fennel, escarole, kale, etc. But we're adding crop varieties within our software. So you can see these things like lettuce. We offer more than 30 varieties in our software, also for microgreens and a couple other crops. So I believe I said this was going to be a lettuce farm. So let's model a few different types of lettuce in here. So I'm just going to choose a couple different varieties. Oops. Okay, so I chose Nancy lettuce or Nancy variety. Here it's going to give you a selection of different grow system types that you can use in the facility. So I'm going to choose ebb and flood, ebb and flow, or ebb and flood. So let's do 33%. I'm going to add a couple more types of lettuce to this model.
David, while you're doing that, I just wanted to ask you a question that was in the Q&A. Where do you get your climate data? Just so folks can understand maybe the source or the quality of that data.
We get it. I can provide the actual website later on, but it's a European, like a European government climate website. I can't remember specifically who the operator is, but it's some European government climate website. Yeah, and feel free. I'm not looking at the chat or anything like that, so feel free to interrupt me if more questions come up.
I will. There's another question that came in the discussion, which was about retailers buying from CEA farms. And so there was a bit of a question of, are large retailers open to buying from CEA farms or local farms? Hopefully CEA and local is the same farm. And then a comment from one of the growers in the chat said a lot of these contracts go through distributors, and the large retailers often look for partners that can scale with them to meet supply quotas. Other strategies are partnering with a co-op or distribution partner that the large retailers go to for product. And so the original question asker responded, said, provided the CEA facility is local, a lot of the CEA produce here in Hawaii is labeled local, although the facilities in California or even Pennsylvania. So any comments on, the retailers buying from CEA facilities? Any comments on that kind of line of?
Yeah, I would say that in theory, retailers are very, very open to purchasing from CEA facilities. And the reason for that is, retailers want to be able to offer a consistent supply throughout the year to their customers, right? And CEA facilities are more able to guarantee that consistency in year-round production than field agriculture, right? Field agriculture is more, there's more chances of interruptions. There's switching of production sites from California to Arizona, if we're thinking about lettuce specifically, right? And weather events, of course, can interrupt that production. So I think in theory, a well-run CEA facility that definitely retail partners are excited to partner with them for sure. Okay, so back to my model here. I've chosen 3 different types of lettuce. I can choose to switch on or off organic production. Now this switch, what it will do is it's going to increase the cost of the inputs for this facility. So it's going to increase cost of things like nutrients. It's also going to increase the retail price that's suggested when the model is created. It does not consider technical aspects. For example, this is a farm I'm modeling in Belgium, which is part of the EU, and the EU does not permit organic hydroponic production. So from a technical standpoint, you actually cannot do organic hydroponics in Europe, but our software doesn't know that. So it's just about the economics. The next question for a vertical farm is regarding the insulation level of your facility. And so I was buying a warehouse, right, in Brussels, and that warehouse may need a significant amount of retrofit so that it is, fully insulated from the exterior climate. So we asked the user to kind of suggest what is the current state of the property they're using, so we can estimate a cost for that retrofit. So I'll put mid insulation. We want to know the roof type, if it's a flat roof or a pitched roof, and that is because we need to do some calculations around the volume of the space and airflow, and this helps us with those calculations. And now we get to the desired number of grow levels. I had a 25-foot space, so I'm going to put in a large number here just so you can see what happens. I don't think 15 levels are going to fit, so we'll see how the software reacts. Regarding farm labor, it's asking me if I want to be the head grower, if I'm going to hire a head grower. I'm too busy right now, so I'm going to say I'm going to hire a head grower, and I can suggest it gives a suggested salary, which we can override. What experience level is that grower? I'm going to say highly experienced, but this selection goes into a calculation regarding the wastage figure in our model, which you'll see in a second. The farm asks about the farm labor rate. This is very important because labor is a critical portion, right? So let's say, I'm guessing labor is a little more expensive in Brussels, let's say $13. Asks about the financing for your project. Is it going to be a loan? And if so, what's the repayment period and interest rate? Is it equity or are you funding it yourself? We'll say it's a loan. Interest rates are high. We'll say 8% and 15 years. And then it's going to ask you about things like your cost of water, your cost of electricity, and your tax rate. So these, as we know, are all very critical in creating a financial model for your farm. Now I'm going to say, yep.
Before you hit see results, I had one question. Is there a reason why you don't ask about natural gas or other fuel costs? Is it just because it's assuming it's an all electric facility?
So this is a vertical farm, and we're not going to use natural gas. We don't need heating, right, for this facility. If I was modeling a greenhouse, it would ask for the cost of natural gas.
Thanks.
Sure. So I'm going to say hit results here, and I'm guessing it's not going to work. All right. So it's not going to work because I'm suggesting too many levels, right? So here it says I need to be equal to, less than or equal to 13. So we'll say 13. And that's based on a calculation that we do regarding clearance at the bottom, clearance at the top for airflow, and a spacing between levels in your vertical farm production facility. So I'll say see results. Okay, and so what our software has done is created a financial model for this farm. Now, what I tell our users and what anyone should keep in mind when they're using this software, and probably any software, is that our software pulls data from the industry, but we don't know what's going on in your specific location, right? So this model that was just created is sort of like a first step in your financial planning. The second step is for you to really go in and refine this model. And I'll show you how we do that. So the refining can happen in things like the crop pricing. So for example, our software, the price in our database is $2.76 per pound. The pricing that we have is adjusted by country. But of course, if you're selling wholesale versus selling direct to consumer, that price is going to vary greatly. So you can go into our software and adjust the pricing. So I'm going to assume that I'm selling for $4 a pound, right? And it's going to adjust the economics for the project, right? This first slide here gives you kind of an overview of the economics of your project, right? This project is not looking very economically viable at the first take. So we learn a little bit about the project. We see that our our total capex is around $5 million for this facility. And the amount of bed space, the amount of energy we'll use, yield, how many employees we'll have, etc. Now let's look at the capex. So our software breaks down the capex into different categories, which are needed for a vertical farm. And as I said before, it's your job here to kind of go in and refine these things. So one of the major expenses in your facility is the grow system, right? And so any of these things with a caret here, we can open up and get a little more information. So of course, the price for your ebb and flood system in Brussels may not be $22 a square foot, right? So we suggest that users at this point begin to get, quotes or more accurate pricing information for their specific in their location. So you may call a local equipment provider, and they may say, "Oh, okay, that size of system, it's only going to be $17 per square foot," right? And you go in, update these numbers. 17. And I'll hit calculate here, and you'll see that these costs will update. All right, so it highlighted green, it meant it's got updated, etc. Same thing for lighting, right? All these with the caret, you can go through and update these. So for example, we use in this model that was created, we use like a generic LED, gives you information about the LED itself, the number of fixtures, the cost per fixture. You can also update that, right? And it's going to update your model. Same with all the different, HVAC, racking, et cetera, et cetera. So this is the first step, or the first step was creating the model. The second step is really refining all these aspects of the financial model, right? Then we can go to the OpEx. And OpEx, these are all the critical sort of OpEx categories for your vertical farm, as you can see, and we try and break down as much as possible what the usage is, right? So for example, electricity, we break it down by category, the amount of energy used in each category, the electricity rate, and specific cost. Same thing with water. And labor as well, right? So we break down labor we try and break it down, or we break it down by function within the vertical farm, right? Obviously, there are a huge number of assumptions that go into these things, right? And we do our best within the software to provide information on, to give you a better understanding of how of what goes into this, but you can always feel free to reach out to us directly and say, "Hey, I'm wondering about, how this specific number was calculated," and we can give you additional information. But same thing here with labor, right? The way our labor calculation works, it's based on crop type. So we have data in our database relating to leafy greens production, relating to lettuce production, etc. Since leafy greens or lettuce was selected for this farm, it pulls data based on production. So we have data relating to, okay, how much seeding labor is required per pound of yield for lettuce, things like that, right? So that's the kind of data that we have goes into these calculations. But you may be using or planning to use specific equipment that's different for your operation. So please, talk with, the equipment provider, the seeding equipment provider that you're using. Find out how much labor is going to be required, and you can update those figures as needed. So what we're really trying to do here with our software is provide you with the tools, with all the questions you need to ask, and all the tools you need to really move forward and plan a successful farm. And finally, you get an annual summary, a 15-year operating summary for your operation. Gives you yield by variety, as you can see. So you can see like this variety, Nancy, is a much heavier yielding variety than Alkindus. Another thing that's really important to consider when planning farms is the amount of wastage, right? The amount of crop that is not going to develop successfully, not able to be sold, and or potentially you cannot find a buyer for that crop. So we try and estimate realistic values, realistic percentages for this, you know, as part of the financial model. It's something that we see pretty consistently that folks who are planting farms tend to underestimate this, right? But really, as we said, every farm is unique, and kind of working out the kinks takes a little time. So we try and calculate a realistic percentage for this figure. You'll see also that waste adjusted revenue here this first year is much lower than subsequent years. And that's because we allow sort of like a ramp time, because your first crop is not going to be harvested right away. You need to seed that crop, you need to let it develop, et cetera, et cetera. So that's why you see first year's revenue numbers are lower than subsequent years. All right, let me jump into, I know it's getting late, so let me jump into a greenhouse model quickly, and then we'll take a few questions. Or feel free, once again, Gretchen, to interrupt me if there's questions. All right, so let's go into the greenhouse. So I will, Gretchen, do you have a location for a greenhouse you'd like to plan?
Burlington, Vermont.
All right, so we'll say Burlington. And any crops in mind that you want to grow?
Yeah, let's grow high value herbs.
Okay, so there we go. Okay, perfect. So Burlington, oops, here we go, Burlington, Vermont. All right, there's Burlington on the map. So, and we're doing a greenhouse. Do you have do you want this to be a highly automated, low automation greenhouse, or?
Let's just do down the middle. So,
Okay.
neither high nor low in your choice.
Okay, great. And do you own your site where you're going to be planning your greenhouse, or are you looking to buy or rent?
Let's say we own, because there's a lot of times people like get land and they're like, oh, let's build a farm there.
Yeah, for sure. Okay, and are we doing a large greenhouse or a smaller greenhouse?
Let's do a smaller one. Yeah.
Okay, so we'll say 10,000 square feet is pretty small. Generally, anything, for a greenhouse, if you want to do any sort of commercial production, 10,000 square feet is definitely on the smallest end you would want to do. Generally 20 to 25,000 is probably going to be a little more financially viable. So we'll do 20,000 square feet. All right, so we have our 20,000 square foot greenhouse. Now, when you put in your size for your greenhouse, it asks you here, is all the space going to be dedicated to production? Or do you need a head house in that space or other things? Let's keep it all as production because the site is pretty small already. All right, and you said that you wanted to add some high value herbs, so we can do Genovese basil. Do that in a NFT system. We'll do half of that. And another high value herb could be, let's see. We could do, arugula is not really an herb. We could do thyme. How's that?
Sounds.
All right. I'm not sure why NFT is not showing up. It should be. But anyhow, so we'll say half of our greenhouse is basil, half is thyme. Now, then you need to choose the sort of like the type of greenhouse. A light duty greenhouse is more like a high tunnel. Medium duty is a polycarbonate greenhouse, and heavy duty would be a glass greenhouse. For your specific environment, I would choose either medium duty or heavy duty. So we'll choose medium duty for now. But the beauty of this, this software is that you can create unlimited models. So you can create run this model with medium duty and then go back and run it with heavy duty and see what happens. And just for fun, we know that Burlington, Vermont is cold. We're going to need heating. We're going to need supplemental lighting. But I want to run the model without those just so you can see the results. And then we'll switch those things on to see a comparison. Okay, Gretchen, are you going to be the head grower or are you going to hire someone?
No, I'm going to hire someone.
Okay, great. We'll hire someone. Here's a suggested salary. Let's see. Okay, I'm going to leave these things as is just because we're running out of time. Let's say see results. I'm going to close my back door because there's a little bit of noise. Hang on one second.
No worries, David. Keep any other questions coming. I think this is a great demonstration of how design software can help identify more questions that you might need to ask before getting a farm started.
Okay, so we ran our model here, and you can see that this model looks to be more financially viable at the start than the model we ran previously. And so we have our, gives us the same metrics as before. When we look at the CapEx, right, we have similar kind of growth system. We did not choose lighting for this. So there's, no lighting, no heating. We have an expense for cooling. Our software will models cooling. We do not model closed greenhouses. We're modeling like a pad and fan or an evaporated cooling system. We would like to add other types of cooling within our software in the future, but this is the only kind of model that is functional at this time. We did not include CO2 injection. Anyhow, so you can see the expenses related to this operation. Similarly, if we go the OpEx breakout, right, it gives us our expenses for ventilation, pumps, etc. And you can see that since we didn't use heating, right, we have no expense there. And let's look at our production here. Our total production is around 20,000 pounds, right? So keep that in year one, 20,000 pounds. Now what I'm going to do is go back and edit the project. And I'm going to turn those three things on. So I'm going to turn on heating. I'm going to turn on supplemental lighting, and I'm going to turn on CO2 injection. So what we did, originally in the model is the climate model uses the climate data that we have and models the crop growth under those climate scenarios. For each crop that we model within our software, there's a number of data points relating to crop development, light requirements, temperature requirements, things like that, right? And so when these settings are turned off, obviously it's using the kind of natural or the temperatures and environmental conditions to run that model. When we turn these things on, it creates the software creates sort of an optimal environment for that crop and runs the model. So I know there are other software models where you could say, okay, what will this crop yield at if we have our greenhouse at 76 degrees or 78 degrees or a CO2 level of 800 ppm or 1000 ppm. If we run this lighting cycle or we run that lighting cycle. Our software is not like that. We have what we assume to be our kind of optimal conditions for each crop. And based on whether these settings are on or off, the lighting, the heating, and the CO2, we just automatically, or the software automatically assumes those conditions. All right, so we're running the model now that we've turned those things on. And we can see that our payback period went from about 7 years to 3 years. So, and if we go to our annual summary, we see that we had around 20,000 pounds, 21,000 pounds in our initial year. And, when we add supplemental lighting, because it is quite dark in Vermont during the winter, when we add heating, it's quite cold as well. Our production increases significantly. So
Thanks for
that
demonstrating
is,
that.
yeah, for sure.
We had one question in the chat. Does the software take into consideration any things like greenhouse curtains or things like solar panels? Maybe either or both?
In terms of, we do not, there's nothing relating to solar panels in the software. We are interested in developing we're interested in developing an agrivoltaic model. We know agrivoltaics is something that's interesting to a lot of people, and it's something that's beginning to take off in different parts of the world. So we are interested in developing an agrivoltaics model for this, for our software. It's something that's on our drawing board, but it's not something we've been able to get to yet. As far as specifically using solar panels, we don't have any integration for that. But theoretically, you could come to your project edit page here, and you could enter the cost of your solar panels as part of, so this is sort of like a little workaround. Let's say you were saying you were buying your site area. You could add the cost of your solar panels to this, the cost of your space here, and then enter into your energy price, the cost of the electricity that you're getting from the solar panels.
What about,
so that would be, yeah, go ahead.
Yeah, that sounds like a good workaround to add in the capital costs and then adjust the electricity cost for things like solar. For agrivoltaics, that sounds like definitely a new module because you'd have to account for the change in light transmission. I had a question too, though, with greenhouse curtains, because they have such an energy saving benefit. Is that a module or a piece of technology that is currently available to turn on in the software, or is that something you plan to do?
It's something we would like to do. But it's something that we have kind of on our drawing board, saying we'd like to do, but it's not within the software at this time.
Well, thanks for sharing. I really appreciated you demonstrating the change of how much production can happen when you start adequately conditioning the environment, and also showing how the payback periods of the investment change as you, say, put in more capital investment or get out more product. So I really appreciated this demonstration of why design software is an important part of the CEA planning process. So any last takeaways, David, you wanted to give the audience?
One more thing that I just wanted to share is that after you create your models in our software, you can download them. We know lots of people, like to create models in Excel. So you can download a version of your model into Excel. It doesn't give you, of course, like all the calculations that go into it, but it does give you all the data that you see in the kind of dashboard that I showed you. So you can take those values and put them into, if you're working with other spreadsheets for your models, you can take those values and put those in. One last thing I just wanted to share is we have a fun CEA related event coming up, a CEA Jeopardy on November 1st. So it's going to be a fun event, and hopefully it'll be interesting to folks in this industry. So if you're interested, it's a free webinar type event. And so please check our website if it might be of interest to you.
That's really cool. Thanks for sharing.
Of course.
Well, thanks so much for joining us today, David. This was really interesting. I really appreciated seeing kind of under the hood, and I hope that our attendees appreciated the value of these types of products, and hopefully we see more of them and wider adoption and use of them. And hopefully this helps more successful farms use less energy and, make more money. So thank you all for joining us. I hope you join us on our November webinar, and thank you for being a part of GLASE's educational curriculum. Hope you have a great day.
Thank you.
Thanks, David.
Bye-bye.